In this video, let's explore unions in the C programming language. Unions provide a memory sharing mechanism that allows you to use the same memory location to store different data types. So, the title of this slide is Unions in C, and the subtitle is Memory Sharing Mechanism. Let's dive in and see how unions work. Now let's look at how to declare and use unions in C. Unions are declared using the union keyword, similar to structures. All members of a union share the same memory location. The size of the union is determined by the size of its largest member. Because the memory is shared, only one member can hold a value at any given time. Changing the value of one member overwrites the values of all the other members. Here is an example. We declare a union named data with an integer I, a float f, and a character array str of size 20. In the main function, we create a union variable called data. We assign 10 to data.i and 220.5 to data.f. When data.f is assigned, the memory previously occupied by data.i is overwritten. This is how we declare and use the unions. Let's compare the memory allocation of unions with that of structures. In a structure, each member gets its own separate memory location. In a union, all members share the same memory location. The size of a structure is the sum of the sizes of all its members, whereas the size of a union is the size of its largest member. For example, let's consider a structure data with an integer I, a float f, and a character array str of size 20. The integer I takes 4 bytes, the float f takes 4 bytes, and the character array str takes 20 bytes. So the total size of the structure will be 28 bytes. Now let's take a look at the union with the same members. Here, all the members share the same memory space. In this case, the largest member is the character array str, which takes 20 bytes. So the size of the union data will be 20 bytes. This shows that unions can be more memory efficient than structures when you only need to use one member at a time. Let's examine the memory behavior of unions with an example. We will declare a union named data containing an integer I, a float f, and a character array str of size 4. Inside the main function, we create a union variable called data. We assign the hexadecimal value 4142444 to data.i. This means that the integer I now holds the value 4142444 in hexadecimal. Then we print the value of data using the format specifier x, which displays the value in hexadecimal format. Next, we print the value of data.str using the format specifier s, which treats the bytes in memory as a string. Because of little endianness, the bytes are stored in reverse order. So the hexadecimal value of 44 corresponds to the character D, 43 corresponds to C, 42 corresponds to B, and 41 corresponds to A. Therefore, the output of the program will be data.str as DCBA. Let's see some common use cases for unions. Firstly, unions are helpful for conserving memory. When memory is limited, unions can help save space by allowing different data types to share the same memory location. This is useful in embedded systems and other resource-constrained environments. Secondly, unions facilitate type punning. Type punning means reinterpreting data in different ways without explicit type conversions. For example, we can declare a union containing a float f and an integer I. If we assign the value 3.14f to u.f, then we can access the same memory location using u.i to get the integer bits of the floating point number. Thirdly, unions are helpful in creating variant types, which can hold different types of data at different times. For example, we can define a union called value that can hold an integer I, a float f, or a character pointer s. However, there are limitations and cautions. Unions have type safety issues because there is no type checking. Endianness can also be a concern when transferring union data across different platforms. Alignment issues can also arise. Finally, reading from a member that was not the last one written to the union results in undefined behavior. These are some common use cases for unions along with some important considerations. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.